Hello everyone, hello. Hello. Welcome to the lecture. How was your long weekend going? Good? Yeah, had a break? Amazing. I hope you get some refreshments so you are ready for the new content. Ooh. Sorry, echoing. Okay. Can you online hear me? Okay, cool. So I hope you had a good break and you are ready for iteration 1 and all the new contents in the courses. So far, as you can see, we have talked about correctness in the dynamic verification last Wednesday, and we had a replacement lecture on Thursday last week, which was replacement for the Monday lecture this week, which falls on a public holiday. So if you haven't watched the recording yet, I strongly recommend you to have a look at that recording. That lecture was talking about teamwork. So if you have questions like, what should I do if my team members is disappeared? Or what should I do to prepare for potential conflict? Or what should I do if my team member prefers to work during midnight while I'm a morning person? So we have a lot of discussions on how you can manage your teamwork and also what is requirement from this course about teamwork. One element, like one assessment element this term, which is new in the project, is evaluation of teamwork. So how you perform as a good team member will impact your mark in your project. So have a look at that lecture if you haven't. So today we'll talk about more about projects. So this is the second lecture about projects. So how we can have a project that different people, team members can collaborate on and make sure that the task can protect your project from bugs and potential errors. And if we have time, we will also talk about static verification, which is a very exciting topic. But I will let's see how much we can get to for static verification. Okay, so let's get on to this topic, which is continuous integration. So this is the lecture within the project group of lectures. We'll talk about, so this is, what is it and why is it important? So last lecture we talked about jest testing. So you now know that you can write a few jest tests that can test your code. But we still need to manually run, for example, npm run jest, right? So that the test can run for you. So is there any automatic way that can help us to run all the jest tests whenever there's a change to your project? All right, so this is what we are going to talk about today. So continuous integration, it is not a tool. It's actually a very good practice of working in a group on a software project so that we merge in all the changes regularly, often, so that if there's any bug, we can detect them quickly. And we can solve conflicts in a small scale so that it's not after 1 week or even a couple of weeks, you have completed a very large feature, and then you merge your code into the master or main. And there may be potentially a very, very big conflict, right? So this is not a good practice. So the good way is that we check regularly and resolve conflicts often. And this is the practice called continuous integration. And For different Git platforms, they have their own tools of helping us with continuous integration. And GitLab, the platform that we use in this course, also provide a great tool for us to implement this continuous integration. And in a more concrete terms, like explanations, with continuous integration supported by GitLab, it helps make the merges into master more frequent and stable, so that we can get feedback often, quick, in a smaller scale. And typically, continuous integration happens in a couple of stages. For some other languages, which also include a compile stage, like continuous integration can start from that compiling, like building stage. But for JavaScript, because it's we do not need the compiling stage, right? So we start with testing, and then there are also more that continuous integration can help us. Like after we have tested, when the project is ready to deploy for the online users to use, like continuous integration can also help with the process. But we'll cover this in other lectures. But now we'll talk more about how continuous integration can help us with automatically testing our change, like any commits. Yeah. And then we can also, it not only can help us automatically run npm run jest, but it can also give us a visual summary of what works, what didn't work, and which step works and which step didn't work. Okay, so are you excited about learning this new continuous integration? Yay! I hope so, because it can simplify a lot of the process. Like, we do not need to manually run npm jest like whenever we make a new change. So how can we actually do that? So given now that we have known that it is important, it has a lot of potential, it can help us, but how? So let's have a look at our untitled project that we created from the very first lecture, and where we keep adding things to it. So now let's have a look at the current stage of this untitled project. So now we had the animal text and hello Git. So these are the text that we added in the first lecture when we were talking about Git. And the date.js was we added during the lecture we talked about JavaScript. And the last lecture, last Wednesday, we added 2 new files which are about like testing. The first one was the Jest lab. We had 2 wonderful students came here in the last lecture, yay, who helped us write this code. And we also had a test file that we wrote together in our last lecture. So how can we use continuous integration to automatically run the Jest test? So in GitLab, if we want to have this continuous integration, we need to add a YAML file. Remember what is YAML file? In the lecture where we talk about what is JSON, the data interchange format lecture, we mentioned that other than JSON file, there's another interchange data format which is called YAML. And we need to add this YAML file which contains the stages or the steps that we want to have this testing. Okay, so these are quite boring concepts at the beginning, but let's have a look at the more interesting parts. So this is how YAML file for the CI, the continuous integration, look like. Remember that this is how the syntax of YAML file. So it's different from JSON file. The tabs matters, right? But it's basically a data format, like we cannot execute the file, so similar to JSON file. So it is a file that containing some data in it. So this is YAML file, and it's used in GitLab for continuous integration. We will introduce what like each line means and what they are doing here, but let's have a try adding it and see how it works, and I will explain them in detail. Okay, so what we need to do is we copy them and go to our untitled project. Let's add a new file on our main branch, and this file have to be Git. So when we are setting up CI, which is continuous integration on GitLab, the file name have to be gitlab-ci.yaml file, so that GitLab can find this file in your GitLab repository, and it can recognize that this is the file that we need to find, which includes the step we need to run for the continuous integration. So we need to use this name. It starts with a dot and gitlab.ci.yaml. And let's copy what is in here. Okay. Can you see from the back? And let's get a commit message, commit our changes. Okay, so now when we go back to our untitled project, you can notice there's a blue dot here. Okay, and when you click on it, it says it was running, and now it passed. It means that all the tests that automatically triggered by the CI file was passed. So all the tests was passed, and it was run automatically. Like you notice that when I commit, make a new commit in this repository, it automatically runs. So let's add another change, and you can see the difference. You can see the process. So you can see a green tick here. It means that the test passed. Okay, so let's have a look. So for example, open a random file, the hello file that we created earlier. We are talking about CI. Okay, and let's commit this change. Go back to the project. Okay, so you can see it's pending now, pending. So it's running the test. It's checking, it's running. So it changed from pending to running, and then it will be passed. So you can see that whenever we make a change, make a new commit to our repo, the CI pipeline automatically runs. And we can add the test in this in the pipeline. Okay, so now let's have a look at what is it. Like we add a YAML file, but what are the lines and what they are doing? Okay, so can you see clearly from the back? Yes. Okay. So the main part, like the most important part, like execute the test, is the script here. So we are not actually running any tests yet. So it just said echo hello, and we'll of course pass because there's no fail cases. But we can change it to edit single file. So we can have, for example, npm run test. Okay, so what this will trigger, it is similar as what we run in the terminal, like we run npm run test. But with this CI file, this npm run test will automatically be triggered whenever we make a new commit. Okay, let's commit this change and go back to the untitled project. You can see it's pending now, so it hasn't started yet. And then pending. Change, please. Change. It's still pending. Okay. Oh yeah, it's running now, and then it's passed. So we can also click on it and see what actually is happening here. Does it look familiar to you? Yeah? Where have you seen it? Sorry? Auto marking for the labs. Yes, exactly. So this is exactly like how we run auto mark for your lab, and you will also see this in the future for your project. So, yeah. But you can see that here it runs the JS test, and it passed. And here are the tests like we wrote together in our last lecture for the remove walls. Right, the normal cases, the edge cases, and passed. But we didn't run in the terminal. We didn't command like say npm run test, right? Okay. So what is happening here? So after this demo, you had a like brief idea about like continuous integration run in GitLab, but actually what's happening behind the scene, behind the stage? Let's go back to some theory. So what is happening here is that whenever commit is pushed, all of the code in the commit is taken by another computer. So not my computer, but another computer, and run the test that we wrote. Okay, so there's a dedicated computer called runner. So you can think of this runner as like a server computer, but it's not server. It's a runner, like a computer sitting in the CSE building. That whenever you commit a change in your project, that runner, that computer, will run the test for you. Okay, so this is what's happening, and this runner doesn't only run tests for your project. Right, so it runs all of our 1531 projects. So our labs, our projects, if we have a CI pipeline, it runs on that runner computer. So the runner is just another computer, and its only job is to run these pipelines, all these CI pipelines. But for some other like more commercial Git platforms like GitHub or Bitbucket, it has its own like runner, like arrays of runner. And if you have your own personal like projects on those Git platforms, you can have some like you can use some of the runner for free. But if you have a lot of tests. Like if you want to use a lot of space on that runner, like normally we have to pay for using the runner. But for 1531, as long as your project is under the COMP1531, the general folder, we can use the pipeline, like the CI pipeline, for free. So the school actually pays for us. So if you want to practice having continuous integration for your project, not in lab, not in project, but in your personal repo, it may not work. It may not work because of the runner. So, but for your lab, for your project, it will work. So you can practice in your lab. It will be definitely no problem. Okay, so now let's have a look. What are those? So there are a couple of lines in this YAML file. The first line is image, and then COMP1531-basic latest. So what is this image? So this line defines the Docker image that this CI pipeline use. So what is Docker image? So you can think of like an environment that has some dependencies that the pipeline needs to have to be able to run. For example, Node, Jest, right? Node is like Node or JavaScript, so these are pretty particular ones. And we set up one environment for you, so all the tests, like the CI pipeline will run in the same environment. So there will no circumstances like the pipeline runs on my computer, and the other students say, well, it now doesn't work on my end. So such kind of case won't happen because we all share the same environment. So this is what we define for you. So this is the image. And the cake. So remembering that when we wrote our code on our laptop, we used npm install to install those dependencies. And when we install those dependencies, a folder called node -modules was added after we add dependencies. But these dependencies were not uploaded or not pushed to the GitLab remote repo, so that we can save the space in the GitLab remote repo. Right? However, to be able to run the test, the dependencies needs to be there in the environment so that the test can run, right? For example, the data function. If we do not have the data function packages in the runner, so the runner cannot run any code that using date function, right? However, we only want to install the dependencies once while we're running the pipeline. Right? So for example, if we have multiple tests, so we have an npm run test here, and then we have something similar, but they all use similar or same dependencies. So if we install those dependencies every time, it will take longer. Right? It also use more space. So if so the cake here basically means that do not delete this node module after you run, for example, npm run test, if there are future tests that still needs to use those modules. All right. So this is the cake part. And what about the stages and the testing? So let's have a look, come back to here. So stages and the test here. For example, we have multiple things that we want to test that needs to use, for example, first npm run test, and then something else that we need to run npm run test or whatever other. So we will introduce more testing in the future lectures, because now you only learn just testing, so it doesn't make much sense to you. But in the future lectures, we will learn about other types of testing. So in your CA pipeline or in your CA continuous integration, you want to test different things. So you may have different here. So you may want to separate them so that they make more semantic. So they have more semantic information in that. For example, this is the JS test, or you can say this is the unit test. And in a future lecture, we'll talk about tab test. Okay, so you can separate them so that they have more semantic information, like more meaning in. So you can group them in different groups based on the type of the test or different state. So, however, they both have. So for tab test and unit test, they are both in one stage called checks. So they run in parallel, but we can have different stages. So we can have, for other programming like C, you may have another stage called compile or build. Right? But for JavaScript, we do not need that stage. But other stages, for example, install modules or install packages. So you may need to have another stage where you install the packages. So I have another test, another stage here, package install. Oops, sorry. And then it's in the stage of install stage. And what we do in this step is we npm install so that all the dependencies can be installed. So that you can see that we can break the different steps into groups and different stages. And how's the process? Like, let me simplify a little bit so that we can have a clear understanding. So what about just this one? So we do not npm install yet. So we just have equal hello, which just print out equal hello in this package install stage. We haven't defined test tab yet, so I will do echo test. Oops, what's happening? So when we commit this change, go back to this untitled project. There's an error, so let's see what's the, okay, so this is something that very good with the GitLab CI configuration, because it can detect if there's any problem in your CI pipeline before running the pipeline. Okay, so it should, if there's no problem in your pipeline, it will say the GitLab CI is valid. And then when you commit a new change, it will automatically run the pipeline. But now there's something wrong here. So let's have a look. Stages, install packages. Sorry?
Type test, you forgot to write script.
Sorry, I can't hear.
Type test, you forgot to write script of the checks.
Oh, I forgot to write. Stage checks.
And then you forgot script before I put that.
The last one.
Last line.
Oh, yes, there's no script in it. Perfect, thank you. So what I'm going to do is I add stage checks and then script. Yeah, so you can see that the GitLab CI, they will validate your file. So let's commit this change, and you can see that the pipeline syntax is correct. And then the pipeline is triggered now. So let's have a look. It's running, but now there are different stages. So that GitLab provided with this visual tool that you can see how's the job going. So now we have two stages. One is called check, another is called install packages. And they run in sequential order. So if any of those check breaks here, the second stage won't run. It will stop there. So let's have a look. Oh, you can also look back in your previous pipelines here. So these are all the pipelines that we triggered before. So you can have a history of all the pipelines. So let's have a look at this YAML file. Let's make one of them fail. How should I make it fail? Can we make one of them fail? Okay, so before we do that, another thing that I want to change here is I think we should install packages first before the checks. Right, so to do that, you can just change their order here. So you notice that whenever there's a syntax error, it will identify for you. And if you change their order here and the stage, they will run following the order that you had. Okay. It's pending. So what it means when it shows pending rather than running, it means the runner is busy. There's no space for you to run your pipeline. You need to wait. Right, so you just wait for a couple of minutes or seconds, and then it will start running. You can see that this turns green first. So this is the first stage. And when this finished, it will start the checks. And if there's enough space in the runner, the tab test and the unit test and the check stage, they will run in parallel. So if there's enough space in the runner. Otherwise, they will run in sequential order as well. But they have no dependencies. It doesn't mean that the tab test fail, then we cannot run the unit test. Okay. Let me have a look if there's any question online. What happens when the pipeline is stuck? Okay, so we just showed what happens when the pipeline is stuck. So I think what they mean when the pipeline is stuck is there's no space in the runner that can run your test. it will show pending, and then running, and then pass or fail. And if it fail, it will it will also give you a hint like why it failed. So in this case, it's the YAML file was invalid because there was a syntax error, like we forgot to have the script line. Okay, any questions so far in the room? No? All good? Yeah, question.
You know how you can merge and you can branch, right? Can you make your own pipeline for your own branch?
That's a very good question. So the question was, can we, because we normally make change in the feature branch rather than the main or master branch, right? So can we also have the pipeline run on a feature branch rather than the main branch? So this is a very good question. You need to have the YAML file on the branch so that a change on that branch can trigger the pipeline. So if you only have one, the CI, gitlab.ci.yaml file on the main branch, and you make a change in the feature branch, it will not trigger the pipeline. Yeah, another.
So as long as you have the YAML file, it'll run.
Yes, but it depends. But it's branch specific. Yeah. So what we normally do is we start by having the YAML file on the main branch, and then we check out a new feature. A new branch, a new feature branch, and that branch will have the same YAML file as the one on the main branch. So we can have a look. We can try that out. So what we can do now is this is our Untitled project. I need to pull first, or I just work here. No, let's practice here, okay? So git status. So I'm on my local vegetables branch. What I'm going to do is I want to git checkout to main. Okay, so git status to check how's my main branch. Yeah, all good. Your branch is ahead of the origin main by 2 commits, git push, and we also have the ntrack file, which was the node module. So before we do anything, I'm going to git pull first. Okay, so this is the commit message. So now let's have a look. Git pull. Already up to date. Okay. Am I on the correct folder? Okay, so let's do it in a easier way. I just change to vegetable branch. Okay, and now I make a change on this vegetable branch, and let's see if it can trigger the pipeline. Yep, that'll be easier to demo. Hey, wake up. Wake up. Okay, so let's commit this change. And you can see that there's no tick or pending or running. So the icon is not there. And you can double check here. So this is still the last one like we ran before. So you can check here in the pipeline, like 5 minutes ago. Right, so our new change on the vegetable branch didn't trigger the pipeline. Yeah. So I may have a question here. So because we normally work on the feature branch rather than the main branch, right? So should I also have the pipeline on my feature branch, like having the ci.yaml file on my feature branch? What do you think? Should I? Some yes, some no. Why? Yeah. Yeah.
Code is meant to be broken on the feature branch, so it won't pass the first anyway. Like your YAML's gonna, okay, you're gonna commit something, it might be broken on your feature branch.
Yeah.
You'd have to set up a new YAML to test it. You'd have to do some tests, not the same YAML from the main branch.
So the answer from the audience is having a different YAML file on the feature branch rather than the same on the main branch. If you want one. Yeah. Yeah, can be. Yeah, another question answer. Yeah.
I think you would use the YAML file because the thing is, even if it's a feature branch, testing the functionality, right? It's
Yeah.
better to make sure it runs.
Yeah.
So I think you probably would have one.
Yeah, so the answer was it's better to have a YAML file on the feature branch because we also want the feature branch to be working rather than broken, right? Okay, so now we have different answers. So my answer is there's no strict rules. It really depends. So if you want to test different things on the feature branch, you can have a different YAML file on the feature branch. Right, and you are also right. You also want your feature branch to be working instead of broken. Especially you want your feature branch to be working before you merge it to the main branch. Right, you do not want to merge anything broken to your main branch. Right, so the good practice is so if you have enough space for your runner, it's good that you have something. It's good that if you have a pipeline on the feature branch. However, in most cases we may changing or committing on the feature branch very, very often. Like we make a pop of commits every day, even, right? So we do not want to spend the runner too much. Especially in this course, like everyone's sharing one runner. So if we have a pipeline on each of a pipeline, if we have a CI pipeline on all branch, like the runner will be overwhelmed and everyone will be seeing pending, right? So the practice for 1531 specifically is we do not need to trigger the pipeline of our feature branch whenever we make a commit on the feature branch. But we need to make sure that before you merge your feature branch into your main branch, the feature branch should pass all the tests. Yeah, question.
So would you do it manually before you do a merge quest?
The question was, should we manually test before we merge into the master? That's another good question. So we can add more tricks to the ci.yaml file so that whenever we try to merge the feature branch into the master branch, it will trigger the pipeline. Okay, so this is how we can do it. Let me show you. So the way we do it is by adding something under the text. For example, let's have a look. Yeah, we are on the main branch. Go to the ci.yaml file, and for this install, let's edit it in the single file. Okay, so let's have, for example, this one. We have a script. Okay, so under this unit tab, we specify which stage we should run for the unit test, what is the script to run in this unit test. But we can also have another one called only. So here we gave them some, under specific circumstances, this unit test will run. Only under the circumstances. And the circumstances that we can have is, for example, main. So this test only triggers changes on main branch. Okay, so remember that we will have this YAML file at the beginning on the main branch before we check out create a new branch, right? So this YAML file will be on our feature branch. But we do not want to trigger it every time we make a change on this feature branch. So we add this new line called, only main. So this pipeline will only be triggered when the change is made on the main branch. And we add another one, which is called merge request. So whenever we make a merge request, this unit test will be triggered. Let's have a look how it works. Whoops. Okay, merge requests, and then what I'm going to do is I commit changes. Okay, we still trigger this pipeline because the change was made on the main branch, right? Okay, so what if we have the same? Oh, what if we have the same? So what I'm going, because we already had a vegetable branch before we load these YAML files. So what I'm going to do is I'm going to create this file, this YAML file on this vegetable branch, a new file. Remember what was the name? It was the name was gitlab.ci.yaml. gitlab.ci.yaml. Uh-oh. What happened? Edit. Oh. Delete. Sorry, I'm been messing up a little bit in my vegetable branch. I'm going to have a new file. And this is what's in the file. And the name should be gitlab.ci.yaml. Can't be any other name. And we commit this change on this vegetable branch. You can see that it's not triggered, right? Although we have this YAML file on the vegetable branch, and we make a new commit on the vegetable branch, it didn't trigger this pipeline. But what if we want to merge this vegetable branch into the master branch? Okay, so vegetable branch to main branch, and then let's merge vegetable branch into main. Okay, reviewer. Remember that you have to assign a reviewer for any of your merge requests, like from your feature branch merging to main branch. And we had a question like, should we delete the source branch? It's up to you, but you can keep them. Create this merge request, and then it triggered the pipeline because we had the only merge request. Right? We have the condition there. So when we merge into the master, it will trigger. Yeah.
Is it an and or relationship with all these? Like, does it have to be in main and the merge request, or is it in main or?
It's an or.
So, for example, if you make a commit in main, for example, we change the
Yeah.
lockdown, it also will trigger this.
Yeah.
Is there a way to make it and?
Yes, there are. Yeah. Yeah, there is. So how can we have an main and merge request? It'll be a bit tricky, but we can have other. Yeah.
When you do a merge, isn't it implied that it's going to main anyway?
Sorry, what's the
So
question?
if you do a merge request, it's implied you're merging onto main anyway.
We merge. We create a merge request, but will not automatically be merged until someone approve or click on the merge button. Where's the merge? Passed. Uh-oh. Oh, because there's a conflict. Otherwise, there should be a button called merge. And you should only click on this merge button when there's a green tick before the merge request pipeline passed. If you see the merge request pipeline failed, you should not merge the vegetable branch to your main branch. So the aim is to make sure that your main branch always has the green tick. It should not fail. So you should check before you merge into the master. Does that make sense? Okay, so you can find that it's very helpful. But if you just want to test your vegetable branch, like when you make a change on your vegetable branch, before you want to merge it into main, you can just locally run npm run gist or npm run test. Yeah, so we can save some space in the run, because every time iteration 1 was fine, but for iteration 2 and 3, because we do not require having pipeline iteration 1, but at the end of iteration 2 and 3, we always run out of space in the runner. So you always say pending, so all groups is pending. So we want to save the space in the runner. So you do not have the pipeline running in your feature branch. Only run your pipeline when you merge into the master or main. Okay. Any questions so far? Yeah. I think you are very good at asking questions. The questions are really good. Let me have a look at online and see if there's any question online. Yeah, I think they are doing good. Okay. Cool. Let me go back to the slide. Yeah, setting it up, synthetic, yeah. Yeah, okay, configurations, yeah. Okay, yeah, so this is the process of adding continuous integration into your GitLab project. So let me see if there's anything missing. Yeah, I think that's all for the continuous integration stages test. Yep. Okay. Cool. Okay, let's have a break. Let's come back at 3 p.m. and we'll talk about TypeScript. Okay? So the static verification. Yeah, okay, testing for online. Can you hear me clearly online? Okay, before we start the content of the lecture, have you watched any of the recordings? What do you think of the audio? Because I received a few feedback about the audio in the online lectures, and I'm wondering whether I would need a different microphone for the online audio, or do you think it's okay? Or yeah.
You cut out at the starting. During breaks, when you go back, you cut out for the first 5 minutes. So it's really quiet and you can't hear anything.
Okay. What about in other cases, like?
At the start, it's totally fine, but after the break,
It's okay. I will start slowly after the break.
Can you zoom the screen?
Can I zoom the screen?
Yeah.
Like this?
Yeah.
Okay. Yeah. Okay. I can do that. Yeah. Cool. Any other feedback? Last week in the end of week 2 notice, we sent out a feedback form, and thank you so much for those who replied and provide us with feedback. So not much we have received, only a few. There are questions about how's the difference between the different labs. So we have lab normal, lab enrichment, and lab core. So lab enrichment doesn't take any. So there are 15 labs in total across the term, and as long as you get 10 marks, you get full marks. So yeah, question.
What's the weighting of stars? Because some terms have 1 star, 2 stars, 3 stars.
Oh, it's just how difficulty are the labs, but each one is one. No, but they are more important for your project. So we have noticed that in previous term that students who fall behind are normally who didn't do the labs, or the core labs at least. So we strongly encourage you to do the labs, although they only takes 10% of the mark, but they are very important for your project. So for example, today we are talking about continuous integration. So next week's lab, you have a chance to practice continuous integration. And then after that, the week after, we'll release iteration 2, and you will need to use continuous integration. So the labs will get you prepared for the lectures. Yeah, if that makes sense. Question that we got during the break about this continuous integration is some of you maybe feel a bit overwhelmed, because in 1531, I do understand that we talk a lot of new stuff in the first couple of weeks. So you have been practicing how to write jest tests, and then suddenly we introduce another new concept called continuous integration. It's okay because you will have a few weeks before you actually need to use this in your project. So we have a lecture here today, and then next week you will get a deeper explanation during the tutorial, and then you are doing the labs, and the week after you practice in the project. So there are a few weeks for you to understand, to get tests, to practice for the new concept. And for this continuous integration, the YAML file, you do not need to modify it too much. So it's very basic, just only a couple of lines. So it's not another new language that you need to learn, like a lot of new syntax you need to learn. So you just need to understand what it is, and then and you add this YAML file to your project, and it will automatically be triggered when you make a new commit. So not much that you need to do, it's just you need to understand how it works. Yeah, so it may take a bit time to understand that, but it won't take much time to really, you need to practice or whatever. So you don't need to modify too much in the YAML file. You just need to understand how it works, briefly. That'll be enough. Yeah, and you are not too scared. Well, it shows pending, it shows running, it shows failed. What is it? You are not scared when you see those things. Okay, and you can also look at that. So for example, when you look at the pipelines, we haven't shown it yet. Sorry, I need to zoom in a little bit so that I can, yeah, it's here. And you can have a look at what's happening in this pipeline. So the question is, what is pipeline? So you can think of the pipeline as this. So this is the pipeline. So there's only one test here. Oh, this is only one test, and this is a little bit more common. So this is the pipeline. So you can think of it as a pipe. Like water starts from here, goes through the pipe, and then to another stage. Right? So it's just a process. We call it pipeline. And you define this pipeline, you define this process in the YAML file. And not much change needs to be made in the YAML file, to be honest. Yeah. So you may need to add, for example, you need to add a script, for example, npm run test. That's it for your lab. Okay. And when you click on one of them, you can see something very similar to your auto marking in your lab. So you already seen that, right? So you know how to rate that. So if this so this is success. So this is the script, and this script print out like hello. But for let me find another more meaningful example. What about this one? The unit test. Yeah, so when it's triggered, when you click on it, when you look inside, you can see what passed, what didn't pass. So it's basically the same as when you run npm run jest or npm run test. Right, so these are the core message that you need to rate. Yeah, so above are just general information that you do not need to worry too much about. Yeah, okay. But if you have any questions, just feel free to post on the forum at any time. We have a lot of tutors on the forum helping, and we also have a large number of help sessions. So till now, I think the help sessions has been quite empty. It's not like used well yet. I'm not too sure if you know much about the help session. So you can find the help session timetable on the course website. And we have two different types of help sessions. The full session, so these are the full session, meaning that they are 2-hour sessions. That you jump in a queue, you wait till a tutor call your name, and you can have a one-on-one help session with the tutor. So these are the full help session. And we also have a lot of mini help sessions. So you can see that, so this is for week 2 only. Okay, so these are the for week 2 only, and when week 3, a lot. So we have a lot of help sessions. And if you are not too sure where to, or when are the help session, our tutor also created a help session calendar that you can download and add to your calendar. So this is the 1531 help session calendar. You can find it on the forum, and you can download it like a Google Calendar version or like the MacBook version, so that you can get a reminder, well, there's a help session today or tomorrow, or when is it, or where is it. So it's very detailed. I think it's pretty helpful, I think. Okay, cool. How many have you started with iteration 0? Hi. Oh, okay. Cool. Yeah, sorry, I need to mention another story before we start the next lecture. I just want to remind that please start as early as possible. So iteration 1, and it's different from iteration 0. So iteration 0 is very, very simple. Like you can complete everything in iteration 0 in just one day. But iteration 1 is different. It's different. You need to start early. Have a meeting with your team member, allocate like job to your team member, set up meeting times, do your stand-ups, and others. Start early. Yeah. So I have a personal story to share. So remember a couple of days, there was a heavy rain, like super heavy rain in Sydney. The day before that heavy rain, I noticed that my car almost ran out of petrol. But I think it's okay, I can fill up my petrol the next day. I still have like a couple of kilometers that I can go. So I wait till the next day, and the heavy rain starts when I was driving on the highway. and I suddenly realized I ran out of petrol. And my car stopped in the middle of the highway in the rain for 2 hours, waiting for a police car to tow me away. So the message that I want to give here is that do your homework early. So do not do things like me, like we'll wait till the last day, because you never know what will happen on the last day, right? I didn't realize there will be the heavy rain. I didn't know that I'll be distracted by other stuff, other commitments that I forgot to fill out my petrol. So it was a disaster. So please do your homework early. Okay. An exciting new topic, static verification. So last Wednesday, we talked about dynamic verification. And dynamic verification verify your code during runtime. Remember that you need to run your code so that your code can be tested. Right? The example we used was this one. Right? So we need to have a code, have the test, and then when we run the test, it will. When we execute the code, it can run the test for us. But would it be better if without running the code, if there's any error, or some types of error, like we can get some notes, like there's something needs to be fixed before you run your code. So this is static verification. More particular, in this course or in this lecture, we'll talk about potential errors about tabs. The example that we had, let me find the example. Where is it? Yep, no. Yeah, this was the example. So this is the code. Remember that we used this example a couple of times already. So this many strings is aimed to repeat the string. Oh, this is the wrong one. My code, yeah, this is the right one. So we want to repeat the string for repeat number of times. So this is the purpose of many string. And when we have many string, hello, 5, it should console log hello for 5 times. Right? So this is when everything is going well. However, if my teammates or my team member accidentally use the many string in this way, like 5, hello. Okay, what will happen? Let's have a try. 3.3. So note the file name is my code broken.js. Oh, didn't broke. Oh, right. Should the other way. Should be hello and then 5. Right? And when I note it, it will console log nothing. So nothing on the terminal. So no error message, nothing was console logged. So you may have no idea about what was wrong. Right? So is there any way that we can and then 5. Right. When I note it will. Sorry, I was looking at online. Yeah, muted, sorry. Yeah, cool. So is there any way that we can check whether we are using the tabs properly here? Right, because we had a string here, it can't loop through the string, right? So there's something wrong here. So this is where we introduce the static verification. So can we protect against this? So there are ways that we can do. For example, we can add a test here, like if repeat instance of number, then we console log an error, say repeat argument is not a number, right? So this is something we can do. And then we can also check the tab for the second parameter if it's a string. Otherwise, we'll console an error saying like string argument is not a string, right? If everything goes okay, then we go through this loop and then console log stuff, right? So this is something we can do. There's no problem with it. But is there any better way, right? Like JavaScript is so powerful, right? NPM project, Node.js, they are so powerful. Is there any way we can do it? So we want to prevent from this kind of mismatches between the actual and expected type of variables. So C is type safe, right? So when we declare a variable in C, we need to declare whether it's integer or whether it's a long or double, like what type is it. But in JavaScript, the type is dynamic. It doesn't mean that JavaScript variables doesn't have a type, but its type is dynamic. Remember the example that we used before, like A plus 1, right? So it will be A1. Right, so its type is dynamic. So it's good, it's dynamic, it's easier, like we do not need to declare the type when we want to use it. But it's also give us this kind of potential problem in this case. So we also want to prevent this issue. So we are introducing TypeScript. What is TypeScript? Have you heard of TypeScript? Some yes, some no. So, so TypeScript is the programming language built on top of JavaScript. Okay, so to less overwhelm you, it's not a new programming language. You can think of it like a package that you install, like other package that you install. So that after you install the TypeScript package, you will have you can have other possibilities around JavaScript. So you do not need to think of it like a new it is a new programming language, but to less overwhelm you, you can think of it like a package that we installed so that we have other features that can check the type for us before we execute that. Okay, and this is how it looks like. Except from the type, other syntax is exactly the same with JavaScript. So the only difference is sometimes we need to declare the type. For example, in this case, like the function sum, there are two parameters A and B, and both of them are of number data type. Yeah, so this is the only difference between TypeScript and JavaScript. Like it's type safe, and sometimes we need to declare its type. So to install TypeScript, we only need to run like npm install --safe TypeScript and tsnode. So this is how we install TypeScript. So it's similar as when we install other npm packages, right? So you can just think of it as another npm package. And the way we run TypeScript code is similar to Jest. Like when we first installed Jest, we also had like node-modules-bin and then Jest, and then the Jest code file we want to run, right? So very similar way. Okay, so when we run npm install TypeScript, under the node modules folder, there will be new folders about TypeScript. So let's have a look, actually, rather than me just talking. So this is the folder that I'm going to play with. Okay, so let's install this dependency. Okay, so we added the TypeScript in this project. So now when you go to package.json file, you can see that there's something new called, what was installed? So this one, so TypeScript and tsnode. So now we add two dependencies in our npm project because we run npm install. And then we'll also have some new folders and the node modules, which are this one, the types, TypeScripts, this one, Yeah, and under the bins folder, you can see there's something new called TS node and TSC. So these are installed when we run like npm install safedev TypeScript TS node. Okay, so after we installed this dependency, we can now run TypeScript code. So TypeScript code, as we have seen, looks very similar to JavaScript code. Difference is that we add a tab by using column and then the tab. And our difference is we had a .ts rather than .js. So that by using the file name, like using .ts, so that Node will know that, well, this is a TypeScript code rather than JavaScript code. Okay, and we can run it by using the TS. This is just my code. And stray. So the sum of 1 and 2 is stray. Okay, so this is how we run TypeScript code. Similar to Jest, remember that we add one script in Jest so that we do not need to have the super long line in the command line. Like we add like test then Jest so that we can run npm run Jest or npm run test, right? But similarly, we can also have something called TS node. So this is the one that we can add to the script. So now we can have npm run TS node and then my code .ts. Oh, sorry, there's a typo. TS node. Yeah, so stray. So it works very similar to other packages like Jest, right? Yeah, Jest. Okay, so this is how we run TypeScript code. Another thing that magically happened was when I run npm run ts node my code, a file named mycode.js will automatically be created in this folder, which is this one. Okay, so if you don't believe it, I will do it again because it already existed before. So I will change the name to mycode-1 ts, and when I run npm run ts node -1, sorry, a typo, -1.ts. Where's my -1 ts? Sorry, my fault. So there's another way. So when we run npm run ts node my code, what happens behind the scene is it will create a JS code, and so what happens behind the scene, it will check the tab in my code -1.ts. If there's no tab errors, for example, we had hello and 5 in the wrong way. If there's no error, it will create a similar or same JS code, JS file, and then run the JS file using like node blah 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 blah. But it happens behind the scene that you cannot see it. Alright, so yeah. I hope I do not confuse you. Yeah, okay. But we'll see more examples, and you can. So, in the previous example, in this example, you can see that although we check the tab, but we still run the code. So, what happens if we have something wrong? For example, mycode.ts, where are you? Oh, you are here. I'll change the name back. Oh, I don't change, just keep it. So what if I accidentally had A and 2, right, in my TS code, and when I execute the code, there will be an error message saying that unable to compile type script, argument of type string is not assignable to a parameter of type number, and this is the line where there's a type error. Remember in the previous example, like in the JS file, when we had a hello and file in the wrong order, there's no error message given us in the JS code, right, in the JavaScript file. But now we have created this TypeScript file. Like we defined the type of the parameters of the variables have to be, and when there's a type error, and when we execute the code, there will be an error message saying that there's a type error on this line, and what is the exact error is. Right, so it checks for you. However, it still run the code, it still execute the code, it still happens during the runtime. So remember, initially what we want is without running the code. We only want to check the tab, whether there's any tab error. Right? So how can we do that? So the way we do that is by using TSC. So before we had ts-node, now it's another command called TSC. So let's have a look and try how it works. So TSC and then my code -1 TS. Okay, I will open here as well so you can see the magic here. So you can see that it didn't execute code like without all the error message that we have seen before. There's only just one error message, like say there's a tab error here on this line. So when we run TSC, it didn't run the code, didn't execute the code, but only check the tab. Okay, and here, okay, the magic is here. There's a new file automatically created called mycode-1.js. We didn't have this file before, right? Where did it come? So this is automatically created when we run TSC. So this is actually the process of how we run TypeScript code. It checks its tab, create a JS file, and then run the JS file. So you can just think of TypeScript as another new dependency of TypeScript, something built on top of JavaScript. Okay, and this JS file, this is how it looks like. A normal JS file, no tab declared for A or B. All right. Yeah, question?
How to declare variables in TypeScript?
How to declare variables? Okay, so the question is how we can declare variables in TypeScript. So for example, we can have a const A, and you can declare it as a number and equals to 1. So this is how we can declare a variable in TypeScript. And similarly, we can have other types. For example, const B is a string, and it should be A. Oh, sorry, Q. So this is how we declare variables in type. And the most commonly used tab are just number, string, and boolean, only 3. Yeah, and that should be enough for this course. Only 3 tabs, so you don't need to worry too much about it. Okay, so boolean is const C, boolean equals to true. That's it. Yeah, question?
We don't need like an object type.
That's a very good question. We'll cover that very soon, like how we can declare objects or arrays in TypeScript. Okay, we'll cover that very soon. But anyway, this is how we can run TypeScript code, like how we can check the tab before or without actually execute the code, or how we can execute the code and check the tab. Okay. Yeah, so in addition to adding ts-node to your script, you can also add another one, which is TSC, which will check your tab without executing the code. Okay, so now we can also add to our original first example for the many string. So we can say like the repeat should be a number, string should be a string tab. Right, so now if you have them in the wrong order, and when you run TSC, it will give you the error message. So it's helpful. Right? So you won't given nothing, a blank. Yeah, so you have no idea what was wrong. Actually, let's have a look. My code broken. This is the my code broken, and let's try. So now we can have npm run instead of having all the line here, because we already add the scripts in the npm run. What did we add? We said TSC, just TSC. So you can have your own customized ones. Okay, so just said, oh, I run the wrong code. So it should be my code broken. My code broken. Isn't it? Yeah, that's the right one. Oh, sorry, I forgot TSC. Oh, sorry, TS. But still, yeah. So you can see that there's an error message saying that there's a tab error. Okay, so how to tab script? So we have already seen, like, you can add a column, then the data type falling, so you actually give it a tab, give JavaScript a tab by using tab script. But tab script do not require you to put tabs on everything. So for example, const name is Hayden. You will see Hayden next week, by the way. So if you see, if you use const name Hayden, you do not need to declare name as a string, because TypeScript will identify this by itself. So this is a string. You do not need to tell me. I already know this is a string, right? But for here, so in the function parameter, we cannot know whether name should be a string or number or Boolean. So we need to declare it. So this is required. But for here, like when TypeScript can identify the type, we do not need to declare it. So we have the flexibility. Right. Okay. Cool. So some examples of typing of TypeScript. So there are the most basic script types, such as string, number, and Boolean, as we have mentioned. And this is how we write functions in TypeScript. So for parameters, we will require a type declared, because TypeScript cannot infer the type of the parameters by itself. But the returned data type is optional, because in most cases, TypeScript can infer the type of the returned value by itself. So we do not declare that. But if you want to, you can declare it in this way. So you can add after the bracket a dot and then string. Yeah, but this is optional in most cases. So this is how we use TypeScript functions. Just something interesting that we can do with TypeScript. Like we can have units in tabs. For example, in this one, for the parameter ready, the tab is not Boolean or not number. It's Boolean or number. It means that when you call print if ready, you can use 1, 2, 3, 4, 0, or you can use true or false. Either one will not create an error message, so either one is okay. So give you more options. So in the parameter, you can say dot, Boolean or number, or you can say string or number. So it can have more flexibility. So declaring the type doesn't mean that it can only have one type. So you still have the flexibility. Okay, so we had a question like how we can declare the type for arrays or objects. So this is how we can declare type for array. So for this one, we are declaring ARR array, and the type is array. And in this array, you can have values of type string or values of type number. Either will be fine. So let's have a look. So this one is a little bit different. It's called list. So, okay, let's run it. So we can remember how we can run it. npm run ts node. So ts node will execute the file. TSE will not execute the file. So this is the difference. TS node and then example that list dot ts. What was wrong? Okay, I had a typo. It should be lists. Okay, so it works well with when the input parameter 1 is a string, right? But it can also work well when we had a number. So it can create it can create an array. So this array can either be an array of strings or an array of number. So both will be fine. Okay, so you still have the flexibility. So this is how we declare array tab in TypeScript. Yeah. So this one is like a new syntax that in TypeScript. Like we didn't see it in JavaScript, right? But you will get used to it. So it looks a little bit new to you in this lecture because for most of you, it's the first time you see TypeScript. But you will get familiar to it.
Are we going to write the project in TypeScript?
Yes. For iteration 2, we will change some of our JavaScript code into TypeScript code. So what we are going to do is first change .js into .ts. And we are also going to add tabs in our previous JavaScript files. Yeah. Okay. This is something new, and it's something quite powerful in TypeScript, is we can define a tab of our own. So for example here, we define the tab to be a list item, which can be either string or number. Then we can use this tab in the parameter for item, and later when we declare the array. So we can reuse them. Instead of in the previous example, you can see that we had string or number here, and then string or number here. Right, so it's kind of an abstract of our code, so that we can reuse the tab that we defined, so that we do not need to have like a string or number here and then string or number here. So it simplifies our code, but it's basically the same thing. It's called aliases in TypeScript. Let me see how much we have left. Okay, I don't want to rush to finish everything. I think what you have learned so far is enough to support you this week. So you will see Hayden next week in week 4. The 2 lectures will be delivered by Hayden, and you will see me again in week 5. I will ask Hayden to finish everything in this lecture and then move on to the next lecture. So you will still get the contents in this lecture. Otherwise, that's all for today. Let me know if you have any questions, or you can leave feedback in the form. Yeah, cool. Thank you. Hey, hello. Sorry, just